Hello everyone, my name is Nael. I'm a computational journalist and the creator of Code Like a Journalist, a free online open source course about data analysis and data visualization with TypeScript. In this lesson, we are going to talk about simple data analysis and geospatial data. Simple data analysis is a library that I created and that I use in all of my projects. It works both with tabular data, so CSV files, JSON files, but also geospatial data with geometries, boundaries, polygons. And this is what we're going to do together in this lesson. We are going to use wildfires data in Canadian provinces to answer the following question. How much land have wildfires burnt in each Canadian province in 2023? To do that, we will convert a CSV file containing latitude and longitude of wildfires into point geometries. And we are also going to open a GeoJSON file with the Canadian provincial boundaries. And we will perform a spatial join with these two datasets to find out which fire occurred in which province. If you have a moment, please add a start to the simple data analysis library repo. It's always nice to know that other people are enjoying your open source work. I'm expecting you to have completed the first steps and the pushing further sections because I won't be explaining TypeScript really in this lesson. We're going to focus on simple data analysis, but if you are comfortable with TypeScript, you'll be fine. Also, it could be helpful to use to do the tabular data first, in which we work with CSV files, because we are going to focus mostly on geospatial methods in this lesson. If you want to know when new lessons are available, subscribe to the newsletter, give a start to the GitHub repository, and there's also a link to my contact info if you want to get in touch. So let's start. We can set up everything we need first. So open a new folder with VS Code to install everything that we need. I created another library called Setup SDA. This is what we used in the previous lesson. This will install everything that we need. So you can start by typing in dino-a to give all authorizations, especially to write files, setup SDA. And this script is going to install everything that you need and create all of the files that you need. We are going to use the task SDA to watch main.ts. This is where we're going to code. There is also a note about which version of Dino you should be using. For SDA to work properly, it's best to have at least version 2.1.9 of Dino. To check your version, you can do dino-version directly in your terminal. And if you want or if you need to upgrade it, you can just run dino upgrade again in your terminal and you'll be good to go. So let's start by loading and caching data. So we are going to use the data on the 2023 Canadian wildfires. There's a CSV file that I uploaded to GitHub. It looks like this. You have the link. And so the first thing that we want to do is to create a new table fires inside our in-memory database, just like this. And then we want to load data inside this table. So we can grab the URL. Here we go. So this is a CSV file. It will be fetched and parsed. And we can have a look at the data in our table with the log table method. Here we go. This is what we have right now. Fire names, hectares, burnt by the fires, the cause. So H is for human. There's also N for natural and U for unknown. And we have two columns with the latitude and the longitude. We have around 7,000 rows, so around 7,000 fires. Canada is a pretty big country. So right now, we don't have any geometries in there, but the latitude and longitude can't be converted to points. So you can use the points method to convert the latitude and longitude values to point geometries. So the first argument here is the name of the column storing the latitude. So it's lat. The second one is the longitude, long. And the last argument is the name of the new column that will be created with the geometries in it. So I usually call that geom because it's easy to remember. And it's also how SDA will name by default columns storing geometries. And so now you can see that we have a new column, geom, with our point geometries. Easy. We are not expecting this data to change, so we can just cache it. Let's start by enabling the cache logs with the cache verbose option set to true when we are creating our new in-memory database. And let's use the fires cache method. It's an async function. Here we go. And we can grab the load data and the points method and put it in there. So on the first run, this code will be executed and the result will be stored inside the cache in here. On the second run, if the code here has not changed, instead of running it, it will automatically fetch the data from the cache, which is very fast. So you can see that the script on the first run took almost 300 milliseconds, and now on the second run, it took just 60 milliseconds, way faster. So we have our fires stored as points geometries. Now we can focus on the Canadian province boundaries. So I uploaded another file. This time it's a GeoJSON file. GeoJSONs are a very, very common geospatial data format, especially with TypeScript or on the web, because they are just JSON files with objects, with arrays, and number. So they are very easy and convenient to use in TypeScript. But the structure of the data is quite specific. So one thing that is very important is that it's usually an object with features stored inside an array. And each feature is an object. And in this object, you have a few things. A type, so for example, is it a type? You have a geometry. For example, here, the boundaries, the Canadian boundaries are multi-polygons. Well, this one is. And you have coordinates. Could be latitude, longitude, or something equivalent, depending on the projection that you're using. But usually, it's latitude and longitude. You also have, let's go back to the lesson. So it looks like this. You see, you have features. It's an array with objects that are the features. Each feature has a geometry with multiple coordinates, or just a set of two coordinates, latitude and longitude if it's a point. And all of the metadata is stored inside properties. So here, for example, you can see that we have Newfoundland and Labrador. It's a Canadian province. The name in English and the name in French are stored inside the properties. Now, we don't really have to deal directly with GeoJSONs because SDA will put everything inside a nice looking table. But it's important to know. We'll play with that in a later lesson. So to fetch the provinces, we can create a new table, const provinces, sdb, new table, provinces, and then we can use load geodata. So instead of using load data that you use with tabular data, if you're loading geospatial data, use load geodata. Exactly like load data, load geodata is able to load local files, but also to fetch data over the internet. So let's grab the URL for the GeoJSON that is on GitHub. And let's log the table again. Here we go. We have our result. Oh, the fires are logged before the provinces. Here we go. And so we have our table fires, and then we have our table provinces. And you can see that name English and name French, the properties, are actually in their column. Very convenient. And the geometry is in its own column as well. And it's named geom by default. You can open GeoJSON files, you can open shape files, you can open all kind of geospatial format with load geodata. So this data doesn't need to be transformed. We can just cache it directly. So now we are going to cache the provinces table. So it's an async function again. Here we go. And so now we can just use that directly. By the way, if you're curious, we can test the cache. So to clean the cache, you can run the task clean. So you can see that this here has removed the cache folder, and we can do dino task SDA to run the code for the first time. So it has been done in 1 second, 25 milliseconds. If I save again, it took just 78 milliseconds. So caching data can really speed up your code, not just for fetching data over the internet, but also to cache very expensive computations. Instead of running them every time, you can just cache them. So it will just, SDA will just retrieve the result from the cache. And by the way, you can see that we have fires and provinces here, 2 different files for them. Very nice. Now, we have our fires, we have our provinces. It would be great to know which fire occurred in which province. We can do what we call a spatial join. In the previous lesson, we used the method join. For geospatial data, you have another one called join geo. And usually when I do this kind of joins, I like to create a new table to put the result of the join. So let's create a new variable, fires inside provinces, that will store the result of the join. And then what we want is to do a join geo on the fires table. So we want to know which fire occurred in which province. So we start with the fires and we join the fires with the table containing the provinces. And then we need to decide on a method, a predicate. For that, we have a few options. Let's say inside, because we want to know which fire happened inside which province. And then we have a few options. By default, the join geo will overwrite the data of the fires, but here we want to keep it outside of it. So output table, and I will just name the table the outputted table the same thing as the variable, like this. And so now we can say fires inside province log table. You don't always need to output a table, but I just wanted to show you the option. You can do it if you don't want to to overwrite, to change your original table. So here we go. So now we have fires inside province, and you can see that for each fire, we still have our 7,000 fires. We have geom has been renamed geom fires because it's the geometry for the fires, and now we have name English, name French, and the geom from provinces. So this is very nice. Now we know that this fire here with these coordinates, well, these coordinates, which are inside the geometry, happened in Alberta. And we also have the geometry for Alberta. Nice. And so now it's very easy for us to answer our question. We can summarize our data to know how much land did wildfires burn in each Canadian province in 2023. We can use the summarize method. So we can do fires inside provinces, summarize, and the values will be hectares, because we want the hectares burnt. The categories will be the provinces, so we can use name English. The summaries, we could use a count, so we'll have the number of fires in each province, and also the sum. So we want the sum of hectares inside each province. And we could round the values with, well, just the nearest integer. So here's the answer to our question. In Alberta in 2023, Alberta had 1,208 fires with, I guess, more than 3 million hectares burnt by wildfires. One thing to note about this analysis is that we are using the center of the area burnt by each fire, but a fire may have crossed provinces' boundaries, borders, right? A fire could have started in Alberta and then crossed to the neighbors, to the neighbor provinces. We are not taking that into account in this analysis, right? It's just a limitation to remember. Something that we could have done is to use the fire perimeters, the polygons of the fires, and to compute the intersection of each fire with the provinces to have a more precise analysis. Maybe it will be for another lesson, but we're not doing this here. I tried to keep it fairly simple for the first lesson about simple data analysis and geospatial data. So this works, but maybe we could rename the columns and sort the data. So let's do it. Let's start by renaming our columns. So count could be number of fires. Sum could be area burnt. Great. And now we can also sort maybe the area burnt descendingly. Here, so we can see that it's in Quebec that we have the biggest area burnt. So we have a table here, but it would be nice to visualize this data. We can do that with directly in our terminal with a method called log bar chart. The first argument is the labels that we want to use. So here it would be name English. And after that, it's the values. So here it would be area burnt. And we have a fairly good looking bar chart to visualize our data. These methods like log bar chart, log line chart, log dot chart, log histogram are quite useful, but of course also quite limited. It's really just to have a quick look at your data. If you want to create more fancier charts, you can use observable plot. Plot is installed by default when you set up everything with setup SDA. So I'm not going to explain the syntax for plot in this lesson because the next lesson is just about that. But just so you know, we are creating here a function that will draw a plot chart, a bar chart, and then with write chart, the method, we pass the drawing function and we specify a file path where the chart will be saved. So when you run this code now, you'll see that in output, you have a chart.png and you have a bar chart as an image created with plot. Plot is great because there's a lot of options. We'll see. You can create stunning data visualizations with it. But here it's just a quick example to show you that with a simple data analysis and plot, you are able to work, the two libraries work really well together to create charts. If you want, you can also create maps, right? Because here we have a geospatial data, and usually that's what you want to create. You want to create maps with geospatial data. So again, you have a make map function this time, and I'm going to explain everything about it in the next lesson. But in this function here, we are specifying a specific projection for the map, and then we are drawing provinces and we are drawing fires, and we are putting the result inside the map.png, which is just here. We are using the hectares burnt for each fire to draw circles, and the size of the circles depends on this value. And also we are using the cause of the fires to add colors to the fires. So you can see that human fires, blue dots, fairly small, natural fires, pretty big, and quite up north, where we have less people, and yeah, the fires tend to grow bigger and are more complicated to put down. So you can easily create maps with plot and SDA as well. If you want to export the data, so when we used write data in the previous lesson, it was for tabular data to export CSV, JSON as an array of objects, or Parquet files. But you can also use write geodata. This first example is to show you how to use write data. So here we are just storing the aggregated value, the burnt areas per province as a CSV file. So this is with write data. But if you want to export, if you want to write geospatial data, then you would use write geodata. Right? So here you can see that I'm using the fires table to write a fires.geojson, and the provinces write geodata to write a geojson for the provinces as well. And by the way, this is why I wanted to use the option output table when doing the spatial join, to keep the fires and the provinces with just one column, geometry column, because GeoJSONs can only store one geometry per feature. Something that is really neat when you're using write geodata this way is that if you want to install the geodata viewer extension, you can install it very easily. You click on extensions, geodata viewer. Actually, I have it installed. Yeah, so this one here, you can install it. And now with this extension, you can do a right click on GeoJSONs and select the view map option. And it will show you your GeoJSON data in an interactive map, which is very nice to have a quick look or to double check something in your data, right? Same thing with the provinces. So you can see the Canadian provinces boundaries. And when you click on one, you have the properties showing up, name English, name French. So that's why sometimes you want to write your GeoJSONs, maybe not to share it or maybe not to use it on the web, but just to double check it directly in VS Code. Quite convenient. And that's it for this lesson about geospatial data and simple data analysis. We transformed the CSV file into point geometries. We opened and worked with a GeoJSON containing the Canadian province boundaries. We did a spatial join. We did visualizations. We summarized, we aggregated our data and exported it as well. Quite a lot. I hope you noticed how easy it was to wrangle geospatial data with SDA. One of the library's goals is really to simplify complex data operations and to make geospatial analysis accessible to everyone. So whether you're working with tabular data or geospatial data, you have access to a lot of intuitive methods to help you get your work done efficiently. And since you have SDA integrated with Plot, you can also create pretty cool data visualizations. And it's the topic of the next lesson. So I hope to see you in the next video. If you want to know when new lessons are available, subscribe to the newsletter, add the start to the GitHub repo, the course GitHub repo, and see you in the next lesson.